Assalamualaikum and hi everyone. My name is Muhammad Hariri Arifin. You can call me Hariri. So I will representative my team today to present about this integrated geophysical mapping of a fractured system for geothermal exploration, basically for non-volcanic region in Peninsular Malaysia, which is representative for Pedas hot spring system. Okay, so this is my colleague. So we come from UKM and some of us come from industry partner, which is Geotechnology Resources Sdn Bhd. So special thanks to SEG to accept our abstract to present in this conference. Hope everyone can enjoy our presentation today. Alright, regarding the introduction of study area, Pedas hot spring area consists of granite and schist, which is at site we can see the contact of these two rocks, and basically the main fault here it should be Seremban. The alignment is not east southwest, but not can be observed here. Basically just only few interpreted fault or lineament. So the nearest one may be this one and this one, and then another lineament is here. Okay, so this is our crowd that we can observe, and the study area is here. And then basically their topography is quite flat, and then in average 55 to 59 meter above mean sea level. Okay, next, this is previous work done in 2017, and at that time we already published in Science Malaysiana, so everyone can free download this article using their website, and then everyone can read the detailed work about soil investigation on this area. Basically we use resistivity and MBSW method last time, and we believe the occurrence of hot spring fracture system is like this. And then now today we focus on the left section, when some development plan to be built here, which is hospital Pedas, right? So for finding in resistivity and IP method, so we deploy ABAM thermometer LS2 to get resistivity and IP data, which is in for 4 survey line with 400 meter each, and using pole dipole array. So basically we get maximum depth of penetration around 100 meter for each survey line, and all the survey for data acquisition ready on August 2020. Okay, for PD 1, which is survey line number 1, so basically the rock here, I think we can interpret that quite uniform, maybe consists of granite, and we observe that maybe the fracture zone here is at the bottom of the profile around 80 to 90 meter depth. And then we propose here PDL means propose a drilling location number 5, which is to verify this result. We need to drill around more or less maybe around 70 meter. Okay, basically, yeah, we very confident with this result before we verify with the borehole. So never mind, we proceed with the PD number 2. And then for me and my team, this is very nice result, and then we have correlation with the high changeability value here, and here not so clear, but basically in resistivity profile, uh, we can observe the low resistivity value on the same pattern here and here. Could be the fracture zone, which is we need to verify with the borehole, and then that's why we propose another PDL 3 and 4 here with the specific minimum drilling target more than 30 and 20 meter here. Okay, then in the PD number 3, also the same pattern with the PD number 2 in previous slide. The low resistivity value could be representative the fracture zone with the hot water, or maybe just normal water. So here we put another two proposed drilling location, PDL number 1 and PDL number 2, to verify this interpretation. Alright, and then if we can observe the changeability value here quite high compared to others, so low resistivity and high changeability value for these two zones for me could be something interesting to verify. Alright, line number 4, this zone still same pattern, um, and then quite a bit the fracture zone interpreted here compared to this one. So we try to verify from this survey line. We have PD number 1 until PD number 4. So next slide. Alright, this one we share with all participants today about fence diagram, which is we compile all the survey line, 4 survey line, and then we can see the pattern of the fracture system at the Pedas hot spring area. So for figure A, Google Earth view, so this is existing hot spring, and then the previous work is located here, and then when the proposed new development come to build a hospital here, so we have chances to conduct subsurface study, and we have chances to verify with few numbers of borehole. Okay, for figures B, we try to simplify, try to show the plane of interpreted fault here. So I hope that this figure can make us to easier to understand the fracture system at the Pedas hot spring area. Alright, so this slide show to us about 5 proposed drilling location PDL. So from PDL number 1, number 2, number 3, 4 and 5, which is we compile from resistivity and IP result, and then we put this PDL location to verify either development can be built here or not, which is our concern is maybe the existing hot spring here will be affected or not when new development come to this area. Okay, so this is very clear now. You can see the existing hot spring is here, and then my previous work in 2017 in Science Malaysiana, everyone can read the full paper there. The pattern is something like this, the fracture system. Here is Pedas River, and then we believe maybe fracture system can be verified, but that time in 2017 we don't have any chances to drill to verify our result. Alright, So we use YWE boring machine in February 2021, after we finish in August 2020 the resistivity and IP survey. So basically we have 2 borehole instead of 5. We managed to get the budget only 2 borehole, and then we managed to conduct the drilling until 30.5 meter, and then the second one, deeper part, we put around more 10 meter to make sure either we can capture hot spring or just normal spring. Okay, so this is a result for borehole number 1. So from 0 to 20.0 meter depth, just soil material, which is silty sand, and then we start to capture the granite boulders from 21.0 meter, and then we interpret as boulders lah, and then repeat with the sand material until 30. So from 30, and then we terminate on 31.5 as a moderately weathered granite. You can see here the yellowish color, and then few fractured system, which is we decide that time to move on another borehole location, since basically this area will built by few underground parking for hospital facility. So we discussed with our team to move to another place, which is for borehole number 2. Alright, this is borehole number 2 summary of drilling log. Okay, so from 0 to 19.5 is soil material, and then we start to capture granite body. However, basically more or less is highly weathered until moderately weathered. We go up to 40 meter depth, and then we record the temperature, pH, and RQD value. So basically for this borehole number 2, we capture the maximum value is 31.5 or 32, and then the pH value is 6.5, the highest value 6.5. Okay, so based on the cobalt sample here, you can see few fractured system. This we encounter more water, and then this is example close-up view for fractured system, the fault plane, and then we can see actually silicon side features on this rock sample. Okay, and then this is 2 photos that we try to share with everyone about pH and temperature measurement on site. We don't have specific equipment to lower down the cable into the borehole well to measure more accurate temperature and pH. Basically we use a small water pump to get the water in the morning, and then in the progress of drilling work, and then before we end our drilling work every day. So we will measure at least 3 times, in the morning, in the afternoon, and then in the evening, before we stop our work of drilling every day, right? So This is correlation between borehole number 1 and resistivity and IP result for PD number 3, because this is a location of survey line and borehole number 1 okay. So basically on the top we capture the salty sand. This is from top until 30 meter, and then we got the granite sample, but unfortunately the temperature of water is not the hot water, okay. And then the borehole number 2, deeper part until 40 meter, but also just cool water. So even the fracture system for us here is quite big, but yep, it's not easy to get the hot spring. And then actually this is good news for new development there, because they quite worry if we capture the hot spring system, maybe we need to change a little bit about the layout of a building there. Okay, so for conclusion, yep, for now maybe no hot water yet. Maybe the depth of borehole drilling program is not reach the fracture system that consists of hot water. Or maybe yes, there is no hot water on the left of Pedas hot spring study area. So we need to do more detailed work. Or for now, that I can conclude is it is safe to build a building there for car parking system, which is on the underground condition up to 30 or 40 meter depth, which is no hot water encounter on that target depth. So this is I think last slide, acknowledgement to our grant support from UKM, and then also from our industry partner Geotechnology Resources that provide geophysics equipment for the survey. So thank you everyone for listening my presentation today. My team and me would like to invite everyone to collaborate in our exploration work in geothermal study in Malaysia. Of course, we need to do some more detailed work, and then collaboration will make us some new finding, and then everyone can understand more about fracture system, especially on this study area. So okay, thank you everyone, see you again, bye bye.